All right, welcome back to lecture. Yay. So first, I want to start off with this reminder. I've been blasting you all with this over and over again. Make sure you're going to this server, SSHing into this server, and changing your password on this server. So what that means, I'll give a quick demo of it even here. So just in case somebody out there doesn't know what we're talking about here and hasn't been able to figure it out, what you need to do is open up a terminal wherever you can write like your Docker commands, and go SSH your ubit carols.dcsl or putty if you've used putty before on Windows, dcsl buffalo.edu. You want to type that in, and that's going to log you into the machine. If it asks for this security question, says, do you trust this server? Hopefully the answer is yes, but you don't have to fully trust it. But you want to trust this server. And now it's going to ask me for my password that I set. What password did I use for this? It's a brand new one, like you're supposed to do. And now I'm logged into this machine. When it asks you for your password, the first time it asks you, it's going to ask for your default password, which is your your month, day, birth date, and then the last 6 digits of your UB card number, the 16-digit number on your card. I've heard last night that from the TAs that a few of you, and more directly from Piazza, but I didn't check it from Piazza, but that some of you lost your UB card. So we'll work with you on that. We're going to contact IT and try to get you set with a different default password. So if one of you are in here, we're looking into that. We're working on that. If you've lost your card or you don't have those 6 digits to give, that 16-digit card number, let us know. Email me, and we'll get a different default password for you. But once you are logged in, then you're gonna. Do I just have it in my recent commands? Then you're gonna type password to change your password, and it's gonna be a standard change your password thing. It's gonna ask you for your current password and then your new password twice. I'm not gonna do that because I don't want to change my password because I actually remember this one. And then once you do that, you're done. That's it. For now, anyway. Once you do have that, actually, let me try to do the next step because once you have a machine, and I'll email you with your machine numbers, I'll email your team, and at least one person on your team, so that this one should be a bit less painful, but at least one person on your team should be in there setting up the deployment and using and deploying your app on these machines. So, for example, do I know it off the top of my head? I don't have my VPN on anyway. Oops. Yeah, this ain't gonna work. So once you do get a machine, you're gonna get a machine named something like this, but with a different number here. And if I forgot something, it might be capital CSE. I don't know. It might be a little different. You're going to log into this machine, and that's where you're going to manage your deployment. For this machine, you are going to need to be connected to the UB network. So if you're off campus, set up your VPN. That's why this is going to hang right here, assuming I did get the server name correct. This is going to hang because I'm not connected to my VPN right now. I don't even think I have it set up on this machine. Actually, and there's a workaround for that. Oh, nope, I changed my keyboard. There's a workaround for that, actually. Oh, there. If you go to Carols does accept outside connections. You can SSH into Carols, and then, because I am curious if I got this right, and then from Carols, now you're on the UB network on Carols, and then you can SSH into your machine. DCSL. Oh my goodness, I have type over on. And your password here is going to be the same password that you changed on Carol's. And now I'm on my machine. I can host things. I'm hosting just the default Nginx website just because I was testing it and I want to make sure it was working the way we want it to. And I'm hosting that. If you're on campus on UB's network or connected with a VPN and you go to this URL, you'll see my default Nginx page. So once you get that address, you'll be able to go to that address once your app is deployed and use your app. These are Ubuntu 20.04 machines. They're virtual, of course, virtual machines, and you do have sudo access. You will have sudo access to your machine. So you can get in there and install whatever you need to install to get your app up and running, presumably Docker and maybe Nginx. That's what I don't think I did any Docker, did I? I didn't really do any Docker. I installed Docker, but I didn't set anything up with Docker. So presumably Docker and Nginx, or just Docker and listen on port 80. We need some days off, please. I'm in pain. I mean, I gave you a whole week. And once we're done with all the homework content, things do calm down a bit. In the pace of the class, we got 2 weeks of auth, and then these lectures are, it's not quite like not spring break where I explicitly say you can skip these, because somebody on your team has to be paying attention this week because there's a lot of project stuff here. I swear to God, if you skip these lectures and then come to me in office hours asking me this stuff, I will be livid, because after the last homework content, this is all project material. And some kind of like bonus topics talking about what HTTPS is. It looks like I don't have a good strategy of how we're going to get HTTPS on those servers that we're going to have. I don't know if that's going to happen unless we do self-signed certs, which we might. But then again, I don't have that in the project document. It's not in the requirements, so I don't know if I can just add that requirement at the last second. So probably just not going to do HTTPS on the projects. Okay, now are we going to cover Nginx? Yeah, I guess not web frameworks. I think I'm going to rearrange this content a bit as well. This is where Nginx would go, but I think that should come earlier. So I think I might move these. These examples are, I just build and deploy an app. I just show you the whole process of building effectively Hello World, because you know how to code, you know how to write web apps. But mostly focusing on the infrastructure, the architecture, and actually deploying it and getting a domain name and deploying on a server and all that stuff. Nginx is a big topic in there. I usually do Nginx and Apache. I might cut that back to just Nginx this semester, so then I can give you a more detailed example. And most of y'all will probably end up using Nginx anyway, because it's just nicer, in my opinion. Yeah, the DCSL, it's its own subnet, I believe would be the word, or DMZ, maybe that is the right term. But it's hosted on campus. I believe it's hosted in the third floor of Davis. It should be in that room. These are the same servers they use in Ken Smith's 411. If you take that, which I highly recommend, that teaches you all about using Linux to a very, very deep level. Yeah, don't think about it, Bubber Ducky. Take 411. All right, we're at the point where we better do some slides here. All right, So let's talk about databases. That's what we're here to talk about. Hopefully everybody who's here has changed their password. The number of viewers adds up to about the number of people who have changed their password, incidentally. Maybe a little more than that have changed. And then Monday, unless it's still 75 students haven't changed their password, as long as that number is reasonable, then we're going to set up all the machines. We're going to start that process on Monday. So hopefully sometime next week, by the end of the week, we'll have all your machines set up for you so you can start deploying your apps. And for Project Checkpoint 2, whenever y'all submit those, you should have your deployment so you can just say, it's deployed, it's up, you already know the link, go to it. Why do we need to change your password again? Oh my goodness. Well, so there are reasons to that. One, everybody knows the schema for your default passwords. So it's not that hard to guess. If they know your birth date, there's only 6 digits to guess. 6 numeric digits. If you know anything about entropy at all, if you paid attention to my 199, if you took it when I was doing security, you know 6 numeric digits has horrible entropy. Somebody can brute force that in like 0 time. It'll be a matter of milliseconds to crack that hash. And who has access to your hashes? Who has sudo on these machines? Friggin' everybody in the class once we have your VM set up. So everybody is going to have access to your hash. And if they're any kind of competent hacker, they can crack that hash in milliseconds. So you have to change your password because there's 0 security in this default password. Everybody in the class will have access to that password. Or at least everybody in your group. And so make sure it's a password that you don't use anywhere else. Just because even if you do change it to a stronger password, it's very possible that one of your teammates or somebody else in the class can crack that hash. This is one of the dangers of having sudo on a machine, and giving students sudo on a machine, is we do have a lot of security concerns, and that's a big one. If you're using the same password that you use to log into your hub, to MyUB, your classmates can probably, the ones who are, paying attention in class and actually changing their password and, know how to do things, they're going to be able to crack that password really quick. So I know you were joking when you said that, but there are serious security concerns here because everybody's going to have sudo on their VMs. So you have to change that away from the default password of month, day, 6 digits from your card. And by the way, anybody, like if your roommate has access to your wallet and just looks at the last 6 digits of your card, they just have your password. There's no security in these default passwords. No security in them. Please change them. Oh yeah, it's definitely isolated. Yeah, you can't access your, like if you log into Timberlake, you're attached to the CSE file system. You're not going to be attached to that file system, so you won't see any of your files here on these servers. It's disconnected from everything else, but it's not necessarily totally isolated. It's still on the same network to a degree, which is why we're locking it down to only on-campus connections, because it's very possible that you could access something outside of the VMs. It shouldn't be likely. It should take a really advanced hacker to do that. But if the connections are open to the whole world, I mean, there's at least one hacker out there in the world who's capable of doing that. So we want to lock that down, especially when y'all write security vulnerabilities and expose us to risk. We want to make sure that's limited risk. So that really advanced hacker has to be connected to the UB network. And at that point, we can track them anyway. We're going to have their UBIT. You lost your card, what do you do? I just mentioned that like 5 minutes ago. If you didn't post on Piazza yet, shoot me an email. I'm going to talk to IT and get you a different default password, hopefully. What about students who left the course? Yeah, what about them? I mean, they don't have to change their password, I guess. I mean, they have no repercussion. By the way, if you don't change your password by Sunday, there will be a penalty to pay for that. There will be a grading penalty. When I do individual grade adjustments at the end of the semester for the project, you're going to get a lower score than your teammates if you don't change your password. If an entire team doesn't change their password, they're just getting a 0 on the whole project. I ain't messing around with that. If your entire team can't be bothered to change a password, you're really not taking this class. You're certainly not taking it seriously. Okay, let's do some slides. Change your password. Change your passwords. This is the ridiculous thing. I feel like I'm saying this. I feel like I've already said this so much before today, and now I'm saying it so much today. There will still be students who don't change their password. They're going to ignore all of my emails, all the Piazza posts. They won't watch lecture. They're still not going to change their passwords, and they're going to take a grade hit. And then at the end of the semester, they'll be like, why did I get a lower score than my teammates? It's because you don't pay attention at all, even the slightest degree. And if you have, by the way, if you have trouble changing your password, you actually want technical help with that, see me in office hours. I still have office hours tonight, 7 to 8. Come talk to me. I don't mind staying late if there's a lot of you having trouble figuring out how to change your password. I'll be your tech support. Like, we'll figure it out. Actually, those of you who lost your card, maybe I could just get the hash and crack it. And maybe no, I can't do that. I don't want to do that. That's crazy. All right, let's get on with it. So let's talk about databases today. You need databases in your current homework and in your project. So let's talk about databases. So what a database is a piece of software that's going to handle your disk I/O for all the data that you're going to store. So our first solution in 115, if we want data to persist, and especially if we want it to persist across server restarts. We want to reboot the server, but we don't want to lose all our data. If we're using data structures, we lose all our data because that's stored in RAM. We want to be able to store it in disk. So our first solution is, well, let's just save it to files. Save our data to files. And we had like CSV files. We could have JSON files. We have different formats of data. Databases is taking that to the next level and saying, hey, look, you're storing data on disk. Let me take care of that for you. The databases are going to give you lots of features. It's going to optimize the crap out of the I/O operations, and then it will manage the files. It'll manage that disk storage for you. These databases are set up as servers that are waiting for TCP socket connections. These are TCP socket servers is what a database is, except instead of speaking HTTP like we've seen in this class, databases are going to speak their own language. A MySQL server is going to speak its language. MongoDB, those are the two that we're going to look at. MongoDB server is going to speak MongoDB. They're not going to speak in a protocol like HTTP. They have their own protocols, but they're still going to connect using a TCP socket. Well, hey, attempt to crack your password. Yeah, I don't know what about Piazza invites repetitive questions. We get the same question on Piazza all the time. Any course I've used Piazza, or as a student where Piazza was used, every single instance of Piazza has tons of duplicate questions. But I don't see that when I dabble in other platforms. I've tried different platforms in the past, and I don't see it. Something about the way Piazza's UX is designed, it invites repetitive questions. I've never been able to figure out exactly what it is. But for some reason, using Piazza, students will not read the other questions that have been asked. I don't know what it is. I got all that. So the two we'll look at are MySQL and MongoDB. MySQL speaks SQL, so you're going to send it SQL statements, which is structured query language. You should have seen this at some point in your career up to now. You should have seen at least a little bit of SQL. It might have been way back in 115, and maybe you've never seen it again, but I'll assume you've seen some SQL. And actually with either of these, I'm not really going to cover the syntax of the languages. There are plenty of resources out there. Part of the course, this course is reading documentation. That is one of the learning objectives of this course. So that is, I'll pull that card and say, read the docs. There are pretty easily digestible tutorials on both of these. I know SQL has a W3 Schools tutorial. MongoDB might as well. And what you need from these these databases isn't much. We're not using anything really advanced. And a lot of you are using object models that handle the DB stuff anyway for you, from what I've seen so far in the project checkpoints. So we're going to look at both of these. I'll start with MySQL. MySQL will listen for TCP connections on port 3306 by default. You can change it, but there's really no reason to. 336 or 3306, that port's been claimed by MySQL. Let's just let MySQL have it. There's no issues with that. Just use the default port. Unless you have a good reason not to, I wouldn't be able to think of a good reason to change the default port. But it's going to listen for TCP connections on 3306. And then you're going to connect to it in your language of choice. You're going to find some MySQL connector, some MySQL client code, some client library, and then you're going to use that to connect to your MySQL server. Now, MySQL and MongoDB, since they are servers listening for TCP socket connections, that implies that they are separate pieces of software. You have to download MySQL, run it on your machine, and then have that separate process running, listening for connections on 3306. And then when you start your server, your web server, that server is going to connect as a client, as a TCP client, to the MySQL process that's running on your machine. That's the standard, at least standard development process when you're in your dev environment for connecting to a database. You have to have a database running, and then your machine or your app is going to connect to it. You haven't done any MySQL? I thought we've been doing MySQL in 1.15 for a long time. Maybe it just feels like a long time. I think we've done it ever since the new redesign, but I thought I did some, even when the course was in Java, I thought I did a little bit of SQL. I don't remember. Oh, but you've done personal projects. I should have read the rest of that comment. But you've done personal projects. So hopefully everybody does have experience with SQL. Of course, by the end of this lecture, I'm going to push you towards MongoDB anyway. That's the punchline to today. I'm going to say MongoDB is going to be easier to work with for our purposes in this class. But if you have SQL experience, by all means, use MySQL. So here's some code. The code examples I'll show you, I'll admit these are borrowed slides from 1.16. So the example code, modified borrowed slides, by the way. The code is going to be Scala for what it's worth. So, but the example remains. Somewhere in your code, you're going to provide these three pieces of information: the URL for MySQL, where MySQL is running. That's going to be a URL. The protocol is not HTTP. In my case, I'm using the Java Database Connection Library protocol MySQL, and then specifying the address for MySQL. For this instance, when I have a MySQL running on this machine, that's going to be localhost, and then the database name is the last part of the URL. And you can have a query string. You can add more information through query strings to set more parameters if needed. But that's the URL for connecting to a MySQL database. A username and password, I'm using root and then just some insecure password. When you install MySQL, it'll ask you to set a root password. Whatever you set that to, make sure that matches what you have in your code. You can also set up a user account if you don't want to use root. You can set up a separate account and then use that username instead of logging in as root. And then you're going to make that connection using those three pieces of information, and then you'll have a database connection. In here, in this JDBC library, this is going to make the TCP connection, establish that connection, and give you a way to be able to send SQL statements to the MySQL server. 2015, that's so long ago. I think that was my first semester, and I haven't even thought about teaching 1.15 by then. And that's a while ago. Thinking, because I think, I feel like we've been doing the redesign forever, but yeah, I forget that I've only been doing this for 5 years. 5 years ago, I was a brand new at this. So I have this password, ignoring that this is a terrible password. Of course, you wouldn't have this as your password. This is about as secure as your default passwords that you got to change. But this is a terrible password. But besides that, when you do have passwords like this, never check these passwords into version control. You shouldn't have this password. Like if you have, especially if you have a public repo, if you have a public repo and you're checking this into the repo, and the same is true for like API keys, OAuth tokens, things like that, like we saw over Not Spring Break, where I accidentally leaked my OAuth token on stream. Oops. Don't check these into repos, especially if those repos are public. Everybody with access to that repo now has your username and password, in this case, the root password to your MySQL database. Now they can log into your database and do whatever they want. They can read all the data. They can steal people's credit card numbers. They can, they have full access to your database at that point, especially because we're using root. So never check a password into version control. It's just bad stuff. And also never use the default passwords. If you heard of the Equifax leak, which again, that just seems like it was yesterday, but that was years and years ago. The Equifax leak, that was the developers just using the default passwords in some software that they were using, some tools that they were using. Somebody just found their endpoints, accessed them, tried the default password, and they were in. Like, they didn't even hack anything. Equifax was just totally incompetent. Don't be like Equifax. Like, don't be that incompetent. Change your passwords. Speaking of, change your passwords on carols. Oh my goodness, don't use the default password. You're just asking for security issues. If you're the type of person who's not changing your password on carols, I don't want you as a developer on my team. I don't want you working at the same company as me. Get away from me. You're a security risk. You're a liability. We don't want that. And you're going to make headlines. You're going to leak lots of personal data at some point in your career. Don't be like that. Please, please, please. I don't want to use the services that you develop on. Just be better than that. Yeah, any sensitive information in version control, use the git ignore is an excellent way to do that. Don't even take a chance of getting in that repo. And if you put what Dillis is suggesting here, put all of your sensitive information in one file and then add that file to your git ignore so you know that it's not being checked into version control. And then maintain that separately from the repo and add some default values in that file, like your password goes here when you upload it to the repo. When you push to the repo. With Docker, we can actually set these environment variables. Oh, I didn't even introduce environment variables. We have so what you can do is set this in an environment variable. Set your password, which is a variable that's at the operating system level, or at the machine level. Set that variable on the machine, and then in your code, read the environment variable. That's a very common way to do this. There are multiple solutions. There are multiple ways you can handle this problem. Excuse me. As long as you're not leaking passwords and you make your dev process, your deployment process pretty seamless. So you store your password in an environment variable, and then read that environment variable here, which is pretty simple in any language that I've done it in anyway. In Scala, it's just sys.env and then the variable name to read an environment variable. And in Docker, we can set these environment variables. You see that we set one of them, the home directory. We set that to /root. When I've shown you Docker, we've all done that. You probably have it in your Docker files because you probably just copied my lecture examples, which is nothing wrong with that in that case. And there's that line that says env home /root. That's setting an environment variable named home to the value /root to set your home directory to root. So we can set those variables in Docker, in our Docker file or our Docker Compose that we're going to see soon, and then read those from your code, and then make sure that you don't check the password in from Docker. So either Docker file or Docker Compose, whatever file you want your environment variable set in, you can maintain those on the deployment and then not check those values into version control. Would be one way to solve this. And then once you're connected to SQL, it's SQL statements from there. Sending whatever language you're using, you'll have a way to send SQL statements and send prepared statements. This is just a fixed statement. It does the same thing every time. And if you ever need user data in there, hopefully you've heard this at least once by now too. Except Memtronics apparently hasn't. If you haven't seen SQL, so maybe there are a lot of you who haven't. But if you're using user data, if you're inserting user data into the database, which you're probably doing to get your app to work, then you have to use prepared statements. Please, please, please use prepared statements. It is one of the security risks listed on the project. It'll be a security risk. Is it? Did I add that to Homework 4? It should be on Homework 4. I might have forgot. But if you're not using prepared statements, for example, this is going to insert into the player's table the values, whatever the user's giving me. Oh, I'm not even using, I hard-coded this anyway. But 2 values that the user gave me. If you're just using string concatenation to build this query, you're taking whatever the user gave you and putting it right into your query, which is bad. We want to use prepared statements here, which the syntax is usually question marks. And any time that I've seen prepared statements, the syntax has been question marks, and then you replace those question marks with specific values. Sometimes right in line in Python and JavaScript, I think they just take an object or a dictionary and you put it right in line. But you got to have these question marks. That's a prepared statement. And then the values are treated as strictly values, not as part of the query itself. If it's part of the query itself, there's nothing stopping a user from entering this as their username, which is going to delete your players table and delete all of that data. So once you're using string concatenation, a clever user, a clever attacker, isn't going to just enter their username. They're going to enter SQL statements in their queries. They're going to, as their username. They're going to add this as their username, and now they're breaking stuff. Now they can start destroying things. Or stealing data, whatever they want to do, whatever their goal is. But they have access to your database at that point. So prevent this. This is a SQL injection attack. Prevent this by using prepared statements, and then you're good to go. At least for the course, there are still ways to attack a SQL database, but this is what I'm looking for in this course. This will eliminate the vast majority of attacks, and at least force the attacker to be very sophisticated to look for another attack. If you're vulnerable to SQL injection because you didn't use prepared statements, anybody in this class can attack your database with enough time to practice it. Or if they have access to your repo, they're just going to straight up look at your code, figure out what query they want to inject, and inject it, and you're done. Anyone in this class could do that. To read data, you got to execute a query as opposed to a statement. That's going to return some data. It'll be different in each language, but the query is going to return some data structure of results, or some iterator of that can iterate over results. Then you pull all the results and do what you need with them to be able to get that going. This example is very JDBC and Scala specific, so I won't go into the details. But when you pull something from the database, you'll get the data in some form that you have to handle. So SQL is based on rows and columns. You create a table, and it's really like effectively a spreadsheet. You have columns, you have rows, you have data in each cell. Very structured, very similar to CSV as a format. But what if we want to store something like an array or a key value store? We want some sort of data structure as one of the columns. So we want my only example is songs. I don't feel like talking about songs, but we want some sort of data structure. We want a row where one of the entries is an array, for example. In SQL, this is where we start talking about joins, which is something I won't talk about in this class. But if you want to do this in SQL, joins is the answer. Or you could try something like MongoDB, which isn't going to have you have separate tables. So the answer to this, by the way, for anyone interested, I'll give it real quick. You would have one table which is just going to have all of the non-data structure data. And then whenever you need the data structure, you're going to create a separate table, have a unique ID for each row in the first table, and then in the second table, have that unique ID as one of the columns, and then one entry of the data structure in another column. And then have all of your entries for every data structure, for every entry in the first table. And then you do a join. You say, give me everything from this table with this ID, and then that'll filter out everything else, and then give you the whole data structure for that particular ID. Not the worst thing, but a little more painful than, at least for my taste, than I'd like. But can be necessary. You know, if you're using SQL, that's what you got to do. Without doing anything ridiculous, you could just check in JSON strings, add JSON strings into your tables. That works, but it defeats a lot of the purpose of SQL. SQL has a lot of optimization in it, and adding JSON strings would work, but wouldn't give you any of the optimization. The joins are optimized, especially when you work with what we call primary keys and foreign keys. I'm getting too deep into it. But if you're using SQL, that's something you'll probably have to learn. Or try MongoDB. MongoDB is another option, another database, and it is actually the one I'm going to recommend. I'm going to push you towards MongoDB, if for no other reason, just because I seem to have long debug processes every time I use MySQL. Those of you who were around for Not Spring Break, who actually developed the RoboTA, I had bugs on stream. I bashed my head against it for like an hour, I feel like, and didn't resolve it on stream. It was painful. And it stalled the whole process. MongoDB, I haven't hit roadblocks like that. I should hedge my bets there. But MongoDB, very similar in that it's going to run as a server, a TCP server, but it's going to listen to port 27017 by default. And again, I don't see any reason to change the default ports. Just use the default ports. This is based on documents, where the documents follow the same structure as JSON strings. So in a MongoDB database, if you have something that fits a JSON structure, you just throw it in the database, and then it stores it. So if you're using Python or JavaScript, which the vast majority of you are for your projects, and you use MongoDB, you take a Python dictionary or a JavaScript object, and you just say, hey, database, I want to store this, and Mongo just says, okay, gotcha. I'll store this for you. And that's it. And then the optimization is based on that JSON structure. It's going to look at your structure here and optimize based on the keys for your values. And this is an example. This is general enough that I don't even know what language this is. Looks like Python because it's got an underscore in all lowercase. It's a very Pythonic style. So here I have a collection. You're going to connect to the database the same way we did before. You're going to need the URL, not really a username and password. By default, MongoDB doesn't require a username or password, but you'll need the URL, and that's fine if you keep it that way. You don't need to set that up. I believe by default, I really should look into this. I should have a better answer for you, but I believe by default, MongoDB does not allow outside connections. You have to explicitly allow a connection to come from something other than the local machine. So since it's restricted in that sense, anybody who has access to your machine, to your machine, is going to have access to your database, assuming you're not using user profiles to Linux users to restrict that. But they will have access to your database, so keep that in mind. Once we have the connection, we're going to use the connection to connect to a specific database. And then in that database, we're going to connect to a specific collection. A collection is the parallel to tables in SQL. A collection can have data inserted into it. Here I'm inserting one document, which is a Python dictionary in this case. And then I just insert that. And now the chat collection has this username with this message. Hartloff just said hello in chat. Effectively is the feature we're building here. Oh my goodness, I talked too long at the beginning of the lecture, didn't I? When we want to retrieve data, we're going to use the find method. And find is going to take an object or a dictionary, whatever, a document, I'll say, which is going to check for matches based on what you give it. Here, I'm looking for all documents that have a username of Hartloff. So this is going to return all of my chat messages in this example. If you want everything, if you want the equivalent of select star from in SQL, this is select star from this collection. This is going to give you everything because there's nothing to filter out. You're not giving it anything to filter out. Just say, give me everything. MongoDB is a very loose structure, very loosely structured. Whatever documents you give MongoDB, it's just going to store them. You can have documents in the same collection that follow different schemas. Where schema, like in MySQL, in SQL, a schema is the columns in a table. That's going to be define your schema. MongoDB doesn't have any schemas. It's just whatever you dump in a collection. So a collection can actually have mixed schemas. It's something you have to be careful with. But also, if you want to change the schema, you just start giving it different documents. You don't have to say, you don't have to set up a collection. A collection is just a collection of documents instead of a very structured table. SQL is very structured. That's what the S stands for, in fact, structured query language. You have to create the tables and know the structure of your data before you start using SQL, or else you have to get into migrations. Anybody who's gotten deep into migrations knows that can be painful. Not the worst, but it's extra work. So that can be difficult. But SQL is fast. So my hot take on this: MongoDB is really great for prototyping. Obviously, this is an opinion. MongoDB is great for prototyping, where you don't know the structure of your data. You don't even know what types of data you're going to store. In development, that can be changing all the time. Your schemas can be changing constantly. MongoDB doesn't care about schemas, so when you change your schema, you just change it. You just decide to give it different documents and work with it as you go. So it's very flexible. When your app is in flux, MongoDB is there to adapt with you. Once your schema settles down and you know the structure of your data, then SQL comes in. SQL starts to shine. SQL is very efficient. It's very optimized, very fast. So once you know what your schemas are and you can set up your tables and set them up in a way that makes sense and design your database architecture, all your schemas up properly, then take advantage of all that efficiency and get that speed. So once your app matures and starts settling down in the schemas, switch into MySQL, and you can switch between the two. You're not stuck with your decision, with some extra work, of course. So to get these databases working, we will have to push this off. Sorry about that. I talked too long about the project at the beginning, but Fridays is examples, so it'll actually just bleed right in. I'll just start with this example, Docker Compose. I will go through it quickly. I'll do what I can in 2 minutes, but I'll restart right here on Friday's lecture. So if this goes too fast and you're missing it, don't worry. We're going to start here on Friday. So Docker Compose is going to solve this problem that we have. We want to run Docker. We want to run our app in Docker, and we want to run our entire app in Docker. We want to say, Docker, do your thing, and the whole app fires up. But now we have a database which needs to be ran separately as a separate process. So now we have to say, okay, start the database, now Docker, do your thing. We don't want to do that. But we have this case where we need two separate processes running, two separate pieces of architecture that need to communicate with each other through TCP. And we want to start them both up using Docker. For that, we're going to use Docker Compose, which is going to let us run two Docker containers in one command. So we'll create a Docker Compose.yaml file to do that, which is going to create multiple containers. One, our app, which this has all of the information that we put in the run command. When you have that trailing dot, you map a port, and then this environment variable, this is new, we'll talk about. and then start Mongo as well. We'll start a MongoDB. This we're just going to pull from an image, and that'll run Mongo separately. Now we have a network of services. We have two separate containers running as part of the same app, and these containers can communicate with each other. So now we don't have to worry about downloading and installing MongoDB. We just throw it in our Docker Compose file, and now we have MongoDB running inside of our Docker atmosphere. There's one big issue with this, and I believe one of the project checkpoints I sent out yesterday, I believe this is the issue you're having. We can talk about it if that comes up. But when you start your app, one of the first things your app is going to do is establish the database connection. Well, and that's fine if your database is already running separately from your app. But when we're using Docker Compose, these are going to be starting up in parallel, and your app is most likely going to get to the point where it's establishing a database connection before the database has fully started up. So you don't have a database running, app crashes, and then the database finishes starting up, and it's like, okay, I'm ready for TCP connections, but the app already crashed a long time ago. That's a big problem. We have to address this. I like this solution. If you want to use a different solution, go for it. Knock yourself out. I like this solution. It's fairly clean. It's effective. This solution from UFO Scout works really well, where we're going to tell it to wait for the database to be ready and then start the app. So if we download their code for this wait command, change the mods to make sure we can run it, and then instead of just running our app, we're going to run UFO Scout's wait command and then run our app. And this is going to read an environment variable to know what to wait on. And we're going to say wait for Mongo to start up to be accepting TCP connections on port 27017. Once it accepts a TCP connection on 27017, then exit, and then we can run our app. So we're effectively waiting for Mongo to start up and be ready for TCP connections before starting our app. And shout out to UFO Scout. I never met them. I don't know who they are, but they really bailed us out here. They have a great solution. It's open source. It's Apache licensed. We can all use it, and it's fantastic. And then when you connect to your database, Docker Compose is going to set up a network for you with its own DNS. So instead of connecting to localhost for your database, you're going to connect to whatever you named it in the Docker file. So now it's Mongo is the host name, not localhost, once you set up your Docker Compose. Okay, I was able to hit the key points there quickly. But again, we'll go over that again. Tomorrow I'll go over it a bit slower and explain in more detail what's going on. And we'll see a MySQL example. And I'll actually run an example using Mongo.